Okay, so in this video, we're going to start talking about wave behaviors. In the last couple of videos, we've been talking about what is a wave, some general properties of waves, how to solve problems using the wave equation, which is the only equation in this unit. In this video, we're going to start talking about what I call wave behaviors, and basically any type of wave, whether it's a light wave or a sound wave or a water wave, can experience similar types of behaviors, okay? Different ways that all waves behave in certain situations. In this video, we're specifically going to look at reflection, refraction, and diffraction, and so you need to know what each of those are, some possible applications, and the concepts involved there. Okay, and then later on, we'll talk about another wave behavior, which is superposition and interference. All right, so first of all, the general premise of what we're talking about here is how do waves behave when they meet a boundary, what we call a boundary. And so what does that mean, a boundary? A boundary is basically the line of separation between two different substances, what I call two different media here in the notes. Media is just like the plural of medium. Okay, so when I say two different media, I'm saying like two different like materials or two different objects. Okay, so a boundary is just a line of separation between two different substances. So for example, like let's say you shine a light into glass, the boundary would just be the line between the air and the glass. All right, and so we're going to talk about how waves behave when they meet a boundary. And when a wave meets a boundary, it can either reflect, refract, or possibly diffract. And really all of those are a possibility. Okay, but first we're going to start off talking about reflection. So reflection is the easiest wave behavior to talk about because everyone kind of knows what reflection is. Like you look in a mirror and you can see your reflection. Okay, so reflection occurs when a wave, and again, everything we're talking about in this video applies to any type of wave. Okay, so reflection occurs when any type of wave encounters the boundary between two different media, and it causes the wave to reverse direction. And if you hit a surface, like a flat surface with a wave, basically there's something called the law of reflection that says that the angle that the wave comes in at is equal to the angle that it bounces off at. Okay, so in other words, when a wave hits a surface, it bounces straight back, and if it hits at an angle, it's going to bounce off at the exact same angle that it hits the surface at. Okay, and so there's lots of different examples where you would see reflection in your daily life. Like when you look in a mirror, obviously, that's a reflection, right? Whether it's like your bathroom mirror, or like a handheld mirror. Echoes, if you've ever like yelled into a canyon, and you hear your voice comes back, that is an example of reflection because the sound wave from your voice travels, it hits the wall of the canyon, and it bounces back, and then you can hear that echo. Motion sensors, whether those are like radar detectors that the police use to see if you're speeding, those use the principle of reflection, because basically what they do is they shoot the radar gun at your car, and then the electromagnetic wave hits your car, and it reflects off of your car back to the gun, and the gun processes the information and tells them how fast you're moving. And obviously, if you're speeding, you get a ticket. That's bad. Radar, sonar, those use electromagnetic waves to detect things in the air or underwater, and those also use the principle of reflection. Okay, so for example, radar, like a radar tower, like an airport would have, they can use that to track all the airplanes in the surrounding area. Okay, so those are all examples of reflection. Reflection is definitely the easiest way of behavior to understand. Okay, so just to show you really quickly how that law of reflection might work. Let's say light hits a mirror like this at an angle, and it's going to bounce off the mirror. And the law of reflection says it's going to bounce at the same angle that it comes in at. All right, just kind of using your common sense and plus what we just talked about, which of these mirrors, A, B, or C, do you think is going to get hit by the light from this flashlight? Okay, so the answer to the question is mirror B. Alright, so notice the light comes in, it hits a mirror, and it reflects at the same angle that it came in at. Now, before we move on to refraction, there's something important I need to tell you. So we talked about the idea of the boundary before. So here's a boundary in this situation. Okay, that's just the line separating like two different objects. In this case, the air and the glass. Okay, there's another line that you need to be aware of that's called the normal line. and the normal line is always perpendicular to, that means at a 90-degree angle to, the boundary line. So if you look in this picture, this dotted line right here, this is what we call the normal line. And so when we talk about angles, we always talk about the angle relative to that line, okay, relative to the normal line. So in other words, this angle right here is the same as this angle right here according to the law of reflection. So it's going to come, it's going to hit the surface, and it's going to bounce out at the same angle relative to that dotted normal line, and it's going to hit mirror B. Okay, so that's it for reflection. All right, pause there if you need to look at that some more. Okay, so moving on, just to show you another example of reflection, here you can see a sailor using what's called a periscope to see an object. Even though they're underwater, they can look through this periscope because it's got two sets of mirrors inside. And so what happens is light can travel from an object, like let's say above the water, and the light wave can come in, hit the mirror, reflect off the mirror, go down to this mirror, hit this one, reflect off it, and into the eyes. And so that way you can kind of see, let's say like you're hiding behind a wall, you can see over the wall. Or let's say you're hiding underwater, you can actually see above the water. Okay, and so this could be like a person, like a submarine or something, using reflection basically with the periscope to see above water. Alright, so let's talk about refraction. Refraction, so most people know what reflection is. Refraction is something completely different. Alright, so when a wave is transmitted into a new medium, and remember when I say medium, I just mean like whatever substance the wave is moving in. When a wave is transmitted into a new medium at an angle, what happens is the wave is going to either slow down or speed up. Okay, the wave speed is going to change. Now what happens when the wave speed changes is it causes the entire wave to change direction. In other words, it causes the entire wave to be bent, okay, depending on the density of whatever the new medium is. Okay, so refraction is the wave behavior that happens when a wave goes from one medium to another and bends because its speed changes. Either it slows down or it speeds up. Okay, and so just to talk about a few examples of this, if you've ever seen this optical illusion before, if you put a pencil in a glass of water, you can try this at home, and you look at the pencil actually looks bent to your eyes. And the reason is the light that hits the water bends as it goes into the water because the wave speed changes. And so because the light is bent, the pencil also appears bent. Now this is just an optical illusion. If you take the water out, it looks normal. Okay, so you only see this because of refraction. All right, magnifying glasses use refraction to bend the light to focus the light rays. Your eyeglasses or like a microscope all use refraction to kind of bend the light to better be able to see things. If you've ever played with a prism and made like a rainbow, a prism uses refraction, and what happens is like if you shine a light into a prism, then the light bends and different colors bend at different rates, and so that produces a rainbow. And actually that's how rainbows appear in the sky. I don't know if you ever learned in elementary school how rainbows are created, but basically sunlight from the sun hits a water droplet, and when it goes into the water, the light bends and different colors bend different amounts, and so that's what causes rainbows to form. And so refraction is kind of a cool wave behavior. It's one of my favorite wave behaviors actually. Okay, so again, during refraction, the wave speed and the wavelength change. What doesn't change during refraction is the frequency of the wave. Okay, the frequency of the wave stays constant. Okay, but because the wave speed changes, it causes the entire wave to bend. This is just like a demonstration showing you refraction. You can see like a laser is hitting this like piece of glass, and you can actually see it bending when it goes into the glass, and then when it goes from the glass back into the air, it bends the other way. Okay, so you can actually see refraction with your own eyes. All right, so I'm going to link a simulation in that you can play around with if you want. But basically, the simulation allows you to simulate refraction. And so just to show you what that looks like really quick. Okay, so here you can turn on like a laser that represents like a light wave, and you can see when the light from the laser comes in, this dotted line here, that's the normal line, right? And then this line over here is the boundary between the air and the water. So you got air on top and you have water down below. And so you can actually see part of the light gets reflected right here. Okay, part of the light, when it goes into the water, gets refracted. You can see it doesn't go in a straight line, it actually bends. Okay, now something you need to know about is how do you know which way the light bends? Because here you can actually see like this angle down here is less than this angle up here. Okay, so now we're going to talk about how do you know which way the light bends. It all has to do with the density of the two different media. All right, so here's an easy way to remember that. All right, so basically, because air is less dense than water, when the light goes from the air into the water, notice how this angle down here is less than this angle up here. And so what we say is this is bending, it bends towards the normal line. Like the angle gets like closer to that dotted normal line. We say it bends towards the normal. All right, so when you go from one medium that's less dense, like air, and to a medium that is more dense, like water, it always bends towards the normal. Or if you want like an easy way to remember, whichever medium is more dense, like water is more dense than air, obviously, whichever side is more dense, it should be closer to the normal on that side. Okay, so here we're going from air into water, so the refracted angle is closer to the normal line than the other angle. Okay, but if I were to flip this around, watch what happens. If I were to make the top, let's say I make the top into water, and I make the bottom into air, notice it actually does the opposite. Okay, so going from water into air, because this side is less dense, because the bottom is air now, it bends away from the normal. And notice that it's closer to the normal on the side where it's more dense. Okay, and so if you're going from water into air or air into water, you should be able to make a prediction as to which way the refracted ray is going to bend. Right? If you're going from more dense to less dense, it's going to bend away from the normal. If you're going from less dense to more dense, it's going to bend closer towards the normal. All right, so that's what you need to know about refraction. And then this slide basically talks about everything I just said. Okay, so if you want to add that to your notes, you can do that. If you want to just look at this picture, it kind of like shows you how it should be, going from more dense to less dense, and vice versa. And even though we're talking about light, that's just like to use a specific example. Everything we're talking about applies to any type of wave. It's just light is the most common example of refraction. Okay, if you look at this picture here, it's basically just like this exact same information. Okay, so pause it there if you need to look at that some more. And then we can do a couple quick examples. Okay, so example 1, notice we have a light ray. It starts off in air at the top, and then it's going into water down here. Okay, so which of the following paths, A, B, or C, do we think the light ray is going to take when it goes into the water and refracts? Okay, so A, B, or C, answer example 1 on your own. Okay, so the answer there is C. Because you're going from air into water, you're going into a medium that's more dense. It's going to end up closer to the normal, right, on the side that's more dense. Now, if it was going from water to air, then it would be different. Then it would probably be A. Okay, but the answer there should be C. And just to take a look at one more, this is basically a similar situation, but it's turned on its side, so you kind of have to tilt your head and look at what's happening. Okay, so we start off over here. We've got like a beam of light that goes in. It starts off inside glass, and then it's going into the air. So we want to know, based off of what we know about refraction, which path is the light going to take, A, B, or C? For example, going from glass into air now. All right, try to answer that on your own. Okay, and the answer there again should be A, because we're going from glass into air. We're going into a medium that is less dense, which means we should be bending away from the normal, which is why it's A. Notice that the normal is this dotted line down here. Okay, so that's what you need to know about refraction. The last type of wave behavior we're going to talk about just really quickly in this video is what's called diffraction. And diffraction is basically the wave behavior that says when a wave hits an opening, or like a hole or something, it's going to spread out in a circular pattern. Okay, so it's going to spread out past an obstacle or past an opening. Okay, so this is called diffraction. And I've got some videos I want to show you regarding diffraction so you can see what that looks like. Okay, but notice with diffraction, a wave comes in from the left and it hits this opening, and then when it goes to the opening, it actually spreads out past the opening. Okay, so waves can actually spread out when they hit an opening, if the opening is the correct size. Okay, now it depends on the size of the opening, but either way, you still get some amount of diffraction. If the opening is like too big, then you don't get a lot of diffraction. Like here you can see a wave coming from left to right, and it hits this opening, but it doesn't spread out very much. But if you make the opening smaller, then you get more spreading out, you get more diffraction. And so a couple applications of this that you might have experienced before. Number one, you might not have known it was because of diffraction, but if you put like a radio, let me try and make this picture bigger. Let's say you put a radio around the corner and you turn it on and you go around the corner. Even if you can't see the radio, right, what happens is the radio, if you look at this picture right here, the radio wave, or not the radio waves, the sound waves from the radio are going to spread out. And because they're going to spread out, when they hit this corner right here, they're going to spread out around the corner. And so the boy can hear the radio sound, even though he can't see the radio, he can hear it because the sound wave is going to diffract. Okay, that's an example of diffraction. This little bit right here is just like showing you the definition of refraction, or sorry, diffraction again. Diffraction is the bending of a wave around a barrier. If you like close the door, like just like a crack, and you see the light spreading out right there, that's an example of diffraction. And not to be confused with refraction, which refraction is the bending of light when it goes from one medium into another medium. Diffraction only happens when a wave hits like an opening or a barrier or something like that. All right, so that is diffraction. Okay, so really quickly, last two examples for the video. In the picture shown below, what wave behavior is shown? Okay, so try to answer example, I guess this is example 4. Try to answer example 4 on your own. Okay, the answer there is definitely B, which is refraction. We talked about that before, when a wave goes from one medium to another and it bends because the wave speed changes, the wavelength changes, the wave frequency stays the same, but because of the difference in wave speed, it causes it to bend like that. Okay, so that's definitely refraction. And the last example, this would be example 5. Which of the following wave behaviors is responsible for being able to hear your friend talking to you from around a corner? Just talked about this one. Try to answer example 5 on your own. Okay, this is definitely C, which is diffraction, the spreading out of a wave when it hits a boundary or opening. Okay, so sound wave hits the corner and it spreads out, so it goes around the corner, and so that's how you can hear sound around the corner. Even though you can't see your friend, you can still hear them. Okay, so in this video we talked about reflection, refraction, diffraction, and so hopefully you have an idea of how to solve basic problems with those, and you know some like applications of those 3 different wave behaviors, and you know what the wave behaviors are. Alright, so as always, please let me know if you have any questions, and I'll see you guys in the next video.